Hi! Are you ready for more calculus? Because I am. So I hope you are too. So I can see in this very first one, it looks like it doesn't have any directions, but if you go back to the previous page, we'll talk about finding the derivative. So let's do that. We're just practicing using the quotient rule. And what's the quotient rule again? Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. So let's use that. I've got f prime of x is equal to the bottom. So I've got x squared minus 1 times the derivative of the top. So this would be 3x squared plus 3. Bottom derivative of the top minus the top. So make sure that you're using parentheses. Times the derivative of the bottom, which would just be 2x, all over the bottom squared. And then that's it. We did it. So bottom derivative of the top minus top derivative of the bottom over the bottom squared. And remember, if you can't remember which one to do, think bottoms up, but don't drink and derive. Really, just bottom comes first. Okay, in this one, it says similar to the product rule, there's a very valuable lesson that we will learn about when we're introduced to the quotient rule. So in here, it says find f prime of x by applying the quotient rule. I'm going to see, is that helpful? That's a little helpful. I'm going to do that. So I'm given this function and I'm applying the quotient rule. This is the one, the bottom times the derivative of the top minus top derivative of the bottom over the bottom square. So I'm going to say bottom times the derivative of the top. So that would be 4x minus 1, bottom derivative of the top, minus top times the derivative of the bottom over the bottom squared. And this is a perfectly acceptable derivative unless you are using, unless this was a multiple choice question and then this was one of the solutions. The solution would not be given like this. The solution would be simplified. So let's actually do that now. So we have f prime of x. So if this were multiple choice, I would have to distribute and try not to mess up. 4x cubed minus x squared, you can try this too, minus 16x plus 4. And then I'm going to distribute this negative and a 2x through each term. But there's also a negative. So this would become negative 4x to the third minus 2x squared minus 12x. Then I'm going to keep this x squared minus 4 squared. Yeah, I'm just going to keep it like that for right now. And then if I keep going and I say, okay, well, I'm going to combine like terms now. And I can see 4x cubed and 4x cubed. That's nice. That goes away. I have a negative x squared and a negative 2x squared, which would be negative 3x squared. Those were those terms. Negative 16x minus 12x would be negative 28x. Then I have plus 4. Or x squared minus 4 squared. And then if I take this and I'm like, okay, what should I do with this next? Did I miss anything in here? Just making sure I've got this. I did bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. Okay. And then I put these together. This would be 4x cubed minus x squared minus 16x plus 4. So I'm just going through my work here. Minus 4x cubed. This would have been, ooh, this is something I messed up. Negative times a negative is a positive 2x squared. And then this would be negative, negative, so this would be a positive 12x. Ooh, I messed up a couple things. So this would be negative x squared plus 2x squared is just x squared. The negative 16x and the positive 12x wouldn't be negative 28x. So you can see some issues already that I messed up several things. Negative 16x plus 12x would be negative 4x. And then this plus 4 is okay. Okay, so you can see where even when I'm doing this, I messed up several things just with like simple algebra there. And so depending on when you're doing this, if you're tired, if anything, like it's pretty easy to mess this up, which plays into my lesson down here. I mean, I totally did that on purpose. Okay, I didn't, I just messed up. But it actually plays into my larger point in a second. This would become x squared minus 4x plus 4. So somewhere off on the side, x squared minus 4x plus 4. I can factor this. Two numbers that multiply to get 4, add to get negative 4, x minus 2, x minus 2. So the numerator is x minus 2 times quantity x minus 2. In the denominator, x squared minus 4 can actually be written as x minus 2, x plus 2, because that would be x squared plus 2x minus 2x. But this is squared, so I have to do that twice. So all of this to say, see how I can factor out now? So I'd be left with f prime of x is equal to 1 over x plus 2 squared. So if you had a multiple choice answer, it would be like this, not like this first one. Even though if you were finding the slope of the tangent and you wanted to substitute in, then that would be totally acceptable to use that first one. The valuable lesson in this is found when we do what the directions say over here. It says simplify f of x, then find f prime of x by applying the quotient rule. So what I'm going to do up here is I'm going to factor f of x. So f of x is, and I'm going to write that over on the side, f of x. And I want you to take a minute and I want you to factor this. Same thing with the denominator. No, this isn't a but. Guys, don't even think that way. What are you? I'm just kidding. But it always makes me laugh when I put two parentheses by each other because, you know, apparently I'm 10. And, you know, I do live with an 8, almost 9-year-old boy, so I'm going to go with that excuse. 2 times negative 6 is negative 12. This is how I would factor it. There are lots of different ways, but I think this is one of the easiest ways to do it quickly. So I took the first term times the last term, the A term times the C term, and got this. Two numbers that multiply to get negative 12, add to get negative 1. Would be negative 4 and 3. But you can't just say x minus 4 and x plus 3 because that doesn't make any sense. Divide by my first term, which this is just a 2. So negative 4 divided by 2 will be x minus 2 because you have to simplify this. Over here, I would have x plus 3 halves, but remember this is just telling you what a 0 is. So I can multiply both sides by 2. I would get 2x plus 3 equals 0. So in here, I'm going to say 2x plus 3, and just to be sure I got this right, I would have 2x squared plus 3x minus 4x minus 6. I'm good with that. Okay, in the denominator, x squared minus 4 be x minus 2 times x plus 2. Hey, look at that. So this is still f of x. 2x plus 3 over x plus 2. I haven't done any calculus yet. Don't worry, I'm getting there. We will get to do calculus. F prime of x, so I'm taking the derivative. And just take up, excuse me, this bottom times the derivative of the top minus top. Derivative of the bottom is just 1. That's nice. Okay. This is f prime of x. This would be 2x plus 4 minus 2x minus 3 over the quantity x plus 2 squared. That's nice. Look at this. 4 minus 3 is 1 over the quantity x plus 2 squared. So it looks like about the same writing. You know, like about the amount of space, but there are so many more things. If you didn't notice by the way I messed it up, there's so many more things to mess up over here than there is here. So the moral of the story, what lesson can we learn from the algebraic analysis above? Simplify before taking the derivative or before finding the derivative. If possible. I don't know if this would be on your test, but on the last couple of years, there's always been one problem on that you really have to do this on. That if you don't, you get really lost in the simplifying for a long time. And there's always someone at the end of class that's like still taking a test, and I can see they're really, really upset. And by the end, I'm like, ah, and I just look over their shoulder and I know that they haven't simplified. And yeah, so I don't know if you'll have one like that this year, but in the past, this has been a really big deal that you have to simplify before finding the derivative. This looked like I messed up, and I was really just trying to emphasize this. I don't know. Maybe I shouldn't do these videos late at night, but gotta do them sometime. So next, we're gonna use this. So we've got a graph of f of x and g of x, and then I've got p of x up here, and I've got r of x. Awesome. This says find p prime of 5, which means I need to find p prime of x first. Don't try to substitute until after you find the derivative. P of x was f of x over g of x. So say the quotient rule. Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. So this would be g of x times the derivative of the top would be f prime of x. Bottom derivative of the top minus top be f of x. Derivative of the bottom is g prime of x over bottom squared. So you can either write the 2 like as a little exponent right here, or you can write g of x squared, if that would help you remember to take the g of x first and then square it. P prime of 5 is going to be g of 5, the function value at 5. F prime of 5 is the slope of the tangent at 5, so the slope at 5 on f of x. F of 5 is just the point, like what is the function value when f is 5? G prime of 5 is the slope of the tangent at x equals 5 on g. And then I've got g of 5 squared. Make sure that you're not trying to take g of 25 or anything. G of 5 and then square it. P prime of 5 is g of 5. G of 5 is up here. And that would be at 5 times f prime of 5. So if I go over to 5 here, and I can see f prime is just the slope. So if I count this, I can see I go, let's find 2 points. I can go down 1, 2, right 1, 2, 3, 4. Down 2, right 4 is the same thing as negative 1 over 2. So negative 1 over 2, or negative 1/2. So then minus f of 5, f is over here, f of 5. I already knew I went down 1/2, so I don't have to be more specific. I know from the here to here, like this value is going to be halfway in between because I already counted the slope out. So I know this is negative 3.5. This seems weird because I'm putting in decimals when I just use a fraction, but whatever. I'm going to do that. You could put negative 7 over 2 if you wanted. G prime of 5 is going to be, oh wait, I said, oh, I almost did it. This is f of 5, or f prime of 5 was what I was going to look at, but I want g prime of 5. So I'm going to go over here, and I can see the slope. I go up 1, right 1, up 1, right 1. My slope is just 1. So be really careful which graph you're looking at. G of 5, so this is g of x at 5 is 5. So then I square it and get 25. If I do a little bit more work, I would get negative 5 over 2, which is negative 2.5. Minus a negative, so plus 3.5, which would be 1.5. So 1.5, also known as 3 over 2 over 25. Or I can say this would be the same thing as 3 over 2 divided by 25 would be the same thing as, I shouldn't do this, divided by 25 is the same as times 1/25, which would be 25 times 3, 75 over 2. I'm definitely going to check in with old me on that one and make sure that I got this right. Hold on. Negative 2.5 plus 3.5. And this is why check-in is not 1.5. Silly me. Negative 2.5 plus 3.5 is 1, everybody. Over 25. There, that made it better. If I put lots of boxes around it, it doesn't even, you can't even tell that I made a mistake there when I was just doing algebra. Okay, so I've got 1 over 25. The next one, I'm going to actually go this way only because I see p prime over here and then I see something about p of x here. So I'm going to go left and then this one I'm going to do next. This says find the equation of the line tangent to the graph of p of x. So I just was working with p prime anyway, so that's good. When x equals 5, oh, that's nice. P prime of 5 is what I found before. When I'm finding the equation of the tangent line, I need two things. A slope and a point. The slope of the tangent, also known as the derivative, is p prime of 5, which is 1 over 25. My point is going to be p of 5. And remember, p of x, if I look up here, was f of x over g of x. So that would be f of 5 over g of 5. F of 5 we found before was negative 3.5, so negative 3.5. G of 5 was 5. And this seems kind of crazy. If you're like, no way can I leave it like this. I just can't do it. I can't write it as that. And you need to multiply it, and you're like, I'm multiplying the numerator and the denominator by 2, and I get negative 7 over 10, and you're like, that makes me feel better. Or you want to change it to negative 0.7 because that's the decimal that you know for sure is the final answer. But I'm going to be wild and crazy and just say, you know what? Why isn't that acceptable as my y value? Sure, let's use it. So y minus my y1. Oh, some of you are cringing right now, but I'm going to use this because, again, why not? It's a valid number even though it looks kind of crazy. So y minus y1, and I changed it to plus positive, is equal to m, which was 1 over 25. X minus x1. Ta-da! I found the equation of the line tangent. R prime of 0, which means I get to do something with R prime of x. So if you haven't already, find the derivative. So R of x, remember, is up here. Ready, go. Okay, I'm going to do bottom times the derivative of the top. The derivative of sine is cosine minus the top, which is sine, times the derivative of the bottom, which would be f prime of x, over the bottom squared. The bottom squared would be f of x squared. I want to find r prime of 0, which means I would say r prime of 0, and then I sub in 0 for all these places. F of 0, cosine of 0, sine of 0, f prime of 0, and then f of 0 squared. R prime of 0, this is going to get kind of crazy, but that's okay. F of 0 is, f of 0, it would be down here at negative 5. Cosine of 0, so in my head I think the cosine curve, cosine of 0 is 1. Minus sine of 0 is 0. F prime of 0. If I go over here at f of x and I think, what is the slope at 0? And then I'm like, oh crap, I don't know. If I drew a tangent line here, that was a good tangent line. Did you see that? That was just freehand. I'm so glad that you can see my picture here and be like, you really drew that? I did. This is my hand. Sometimes you just have to be impressed with your own lines. Okay, so, but you see right here how I think, oh, it's probably around 2, but I don't know what it is. This is just some positive number. So f prime of 0, any positive slope, or I can say a positive number times 0 is still going to be 0. F of 0 we said was negative 5 squared. Negative 5 times 1 is negative 5, minus 0 is still 0, over 25, also known as negative 1/5. And if you're like, why did you just simplify that one? Why didn't you keep it as negative 5 over 25? Because I felt like it. I felt pretty confident that I wouldn't mess that one up. But you don't have to. Equation of a tangent line, you need two things. What are they? Slope and a point. Do we feel like you're coming back to an old friend every single time? Oh, I wrote the point first this time. R of 0 and R prime of 0. R prime of 0 we already know is negative 1 over 5. R of 0 is going to be found by going up to that original equation and putting in sine of 0 over f of 0. r of 0, sine of 0. Remember, if I went over here, in my head I'm thinking, okay, sine of 0, this is my sine curve. I would get 0 over f of 0 was -5. 0 divided by anything is still 0, except for 0 divided by 0, and then we don't even want to talk about that because Siri will start talking about like cookies and having 0 friends and splitting them. Not good. Okay, so I'm going to say y minus y1 is equal to m times x minus x1. You could definitely simplify that, or you could definitely keep it the same. Okay, should we do a little bit more? Just a little bit? A little bit more. Were you hoping we had algebra, then we had a graph? Were you hoping that we had a table? Because if so, I'm like the dream maker here, making dreams happen left and right. Okay, so the first one, think about the last lesson. This was just kind of thrown in there, and I've talked about it a couple times, but it really has nothing to do with the quotient rule. If you want to estimate a derivative, so estimate g prime, what do? You did this in the product rule stuff practice a couple days ago. If you said you take g prime and you go over here and you say this slope is at 2.5, so then you're going to take these two values, you're going to add them up and divide by 2. You are very wrong. Don't do that. Don't do that. The slope of a tangent line is estimated by doing the slope of the secant line, and it's of g of x. So I'm going to say g of values close to this. I can pick g of 3 minus g of 2 over 3 minus 2. So I'm finding a different slope on the graph. I'm not just putting random numbers together. G of 3 was -3. G of 2 is -1 over 3 minus 2. If you add these together, you would get -3 plus 1, which is 2. Divided by 1 is still 2. So I'm going to say approximately 2. And then I'm going to do the next one. I'm going to say, okay, which direction we want to go. Let's do this one. So how about you try it? Oh wait, you know what? Silly me. -3 plus 1. -2. Fixed it. So if you're like Mrs. DeWald and you're getting ready to message me, I hope you kept watching for a second because I just fixed it just like that. Next one, p of x is g of x over f of x. What is the value of p prime of 4? And then what does this say about your graph? Give a reason for your answer. So I'm just going to say p prime of 4. I need to know p prime of x. So what is the quotient rule? Bottom times the derivative of the top minus top. Derivative of the bottom over the bottom squared. And you need to write small because there's not a lot of room in this box. Who's your teacher? I don't know. P prime of 4 is bottom, so f of 4, g prime of 4, minus g of 4, f prime of 4. And then be careful, this whole thing is squared. So this would be f of 4, find your answer, and then square it. P prime of 4, and this is where I can substitute stuff in. F of 4, I told you to write small, and then I didn't really write small. Okay, f of 4 is 1. G prime of 4 is -2. G of 4 is 7. F prime of 4 is 8. F of 4 is 1 squared. If I did this, I would have -2 minus 56, which is -58. Oh my goodness, that's crazy. But that's okay. Crazy answers are okay. So if I want to know what this says about the graph of p of x, at p of x, I can see that the slope of the tangent is -58. So what does that mean? I'm going to say p of x is decreasing at x equals 4, and my reason is as p prime of 4 is -4. I'm going to just say less than 0. We did it. Look at this. I have so much room. I'm so excited. Look at this one. Do you see how this is a product, but also a quotient? Ooh. Okay, so what I'm going to do is I'm going to say first, so the product rule, what's the product rule again? First times the derivative of the second. Okay, so the derivative of the second would be the quotient rule. Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. Okay, this one is going to look very nice math-wise because I need to write it underneath. So this would be the first times the derivative of the second plus the second. I'm just writing it down below, even though this is really hard for me to do because it just looks gross. First times the derivative of the second plus second, the derivative of the first, which is b4x. Q prime of 2. You would just be going through and substituting all these things in. So you substitute in everywhere you see an x, you substitute in 2, and then you simplify. And so really what I want, instead of making this video much, much longer, but I will happily send you my work on this one if you want, but substitute in x equals 2 for all of those places, and you should get q prime of 2 is equal to, this is a good time to stop if you don't want to have the spoiler of the answer. Ready, set, go. Negative 72. You would have to sub in x to all of those places. And actually, I have this on a different one. You can see if you want to like stop this frame and see like what the answer is here. There you go. Okay, on that fun note, let's go over here. Find the equation of the line tangent to the graph. We get to end with an old friend. In this one, we need two things. We need a slope and a point. To find the slope, we're going to use the quotient rule. Bottom is g of x times the derivative of the top minus top derivative of the bottom over the bottom squared. B prime of 3 will be g of 3 times 3, so I'll just put that on front, minus 3 times 3 is 9, g prime of 3 over g of 3 squared. B prime of 3, so I'm going over up to my table, 3, g of 3 is negative 3, minus 9, g prime of 3, so g prime of 3 in my table is 6. G of 3 we just said, but I'm going to make sure is negative 3 squared, which would be 9. This would be negative 9 minus 54 over 9. Negative 9, oh sorry, my head's in the way. Negative 9 minus 54 would be negative 63 over 9, which would be negative 7. That's v prime of 3. So if I do y minus y1 is equal to m, I know my slope is negative 7. X minus x1, I know my x value is 3. I just need to find out what v of 3 is, which is 3 times 3, which is 9. G of 3 we said was negative 3. 9 divided by negative 3 is negative 3. Have I told you that I think you're rock stars? Like that you are a rock star. So if you're just one person watching this, which I'm guessing you aren't, but as a class, you're rock stars altogether. You personally are a rock star, and I'm super thankful I get to teach you. So yeah, thanks for being you, and let me know if you need anything at all. Bye.